Okay, next is of problems on difference equation. All the theory parts is already difference equation. The impulse response of the system described by the difference equation, that is y of n plus y of n minus 1 is equals to x of n minus 2 x of n minus 1. Given equation written as it is, then taking DTFT on both sides. Therefore, what I will be getting DTFT if I apply, instead of y of n, I will be getting as y of e raised to j omega plus 1 by 2 e raised to minus j omega, because for this, based on this, e raised to minus j omega, y of e raised to j omega, that is equals to, for x of n, you will be getting as x of e raised to j omega minus 2 e raised to minus j omega into x of e raised to j omega. It's just a shift operation. Same way, e raised to minus j omega is there, means what will be writing x of n minus 1. Delta of is going to be multiplied with delta of n minus 1. If you are getting that, go through that, or else just remember and write this equation. Okay. The frequency response is going to be, take y of e raised to j omega common from this and x of e raised to j omega from this. You will be getting as x of y of e raised to j omega 1 plus 1 by 2 e raised to minus j omega is equal to x of e raised to j omega into 1 minus 2 e raised to minus j. And what is the impulse response? So, right, h of e raised to j omega is going to be y of e raised to j omega divided by output to input, plus 2 into e raised to minus j omega divided by 1 plus 1 by 2 e raised to minus j omega, that is equals to, I can write as 1 divided by 1 plus 1 by 2 e raised to j omega, then minus 2 e divided by 1 plus 1 by 2 e raised to minus j omega I can write. Then taking the inverse, what I can write now, this is like your alpha 1 minus of minus by 2 e raised to j omega I can write. Therefore, impulse response is going to be h of n is equals to minus 1 by 2 power n u of n, because here it is of e raised to minus j omega is there. Are you remember, we changed some parameters based on u of n minus 2, n minus 3 is there, means we modified, right? Based on that equation, I can write as minus 2 minus 1 by 2 here, because 1 minus of minus, okay, 1 minus 1 by 2 power n minus 1. What is the value here? Here it is of only 1 minus j omega, means I can write as minus 1 j omega, right? Means the constant value what it is there is of 1. For that reason n minus 1. If it is of e raised to minus j 2 omega, then it is going to be 1 minus 1 by 2 power n minus 2 u of n minus 2. Here it is only 1, for that reason minus 1 by 2 power n minus 1 into u of n minus 1. You will have to write. Next, obtain the difference equation description for system having impulse response. Here it is given in terms of 2 into 1 by 2 power n u of n plus minus 1 by 2 power n u of n. Then given equation is written, then taking DTFT on both sides, what I can write, h of e raised to j omega is going to be always for delta function it will be 1 only, plus 2 divided by 1 by 2 power n alpha raised to n u of n, means 1 divided by 1 minus alpha, right? So 1 minus 1 divided by 2 e raised to j omega plus here 1 divided by, here minus is there, for this reason 1 plus 1 by 2 e raised to j omega. Then take the LCM. Then if I take the LCM, here a minus b, a plus b. a minus b, a square minus b square, 1 square minus b square you will be getting, therefore 1 by 2 e raised to minus j omega whole square. Then go with the modification of this. After multiplication and all, you will be getting as 1 minus 1 by 4 e raised to minus j 2 omega plus 2 plus e raised to minus j omega plus 1 minus 1 by 2 e raised to minus j omega divided by 1 minus 1 by 4 e raised to minus j 2 omega. Then solve for this, simplify the here. You will be getting as 4 plus 1 by 2 e raised to minus j omega minus 1 by 4 e raised to minus j 2 omega divided by 1 minus 1 by 4 e raised to minus j 2 omega. Then cross multiply here. Therefore, I will be getting as y of e raised to j omega into 1 minus 1 by 4 e raised to minus j 2 omega is equal to x of e raised to j omega 4 plus 1 by 2 e raised to minus j omega minus 1 by 4 e raised to minus j 2 omega. Then multiplying y of e raised to j omega to both the parameter and also for x of e raised to j omega, here for each element it is multiplied. Here it is getting. Then taken inverse DTFT. What I can write here, in this case first it is written here, that is minus 1 by 4, here 2 is there, right? Means y of n minus 2 plus y of n. Then here e raised to minus j 2 omega you will get. Therefore, what I can write now, minus 1 by 4 x of n minus 2 plus 1 by 2 x of n minus 1, because only 1, plus 4 x of n. This is what the equation. Then the next problem is of obtain the difference equation for the system with the frequency response h of e raised to j omega is equals to 1 plus e raised to minus j omega divided by 1 minus 1 by 2 e raised to j omega into 1 plus 1 by 4 e raised to minus j omega. Write the equation as it is and write the equation h of e raised to j omega in terms of y of e raised to j omega divided by x of e raised to j omega. Then take the LCM here. Then multiply for each parameters here. Then solve for this. You will be getting as 1 minus 1 by 4 e raised to minus j omega minus 1 by 8 e raised to minus j 2 omega plus e raised to minus j omega. The denominator part, again you have to multiply 1 into of this and then minus 1 by 2 e raised to minus j omega of this parameter. After multiplication, you will be getting as 1 minus e raised to minus j omega minus 1 by 8 e raised to minus j 2 omega. Then adding of these two, you will be getting as 1 plus 3 by 4 e raised to minus j omega minus 1 by 8 e raised to minus j 2 omega divided by 1 minus 1 by 4 e raised to j omega minus 1 by 8 e raised to minus j 2 omega you will be getting out. Then again cross multiply here, y of e raised to j omega with the whole function, then x of e raised to j omega with the whole. You will be getting your difference equation. Then the next type of problems is of obtain the frequency response of the discrete LTI system represented by the impulse response h of n is equals to 1 by 2 power n u of n. The frequency response of a discrete time LTI system is given by DTFT of h of n is going to be h of e raised to j omega is equals to summation, the basic equation only, instead of x here it is of h, that's it. N varying from minus infinity to plus infinity, h of n e raised to minus j omega n. Here h of n is given as 1 by 2 power n u of n e raised to minus j omega n as it is. Then I can write as u of n, from u of n I can write as the limit is going to be changing, n varying from 0 to infinity, then 1 by 2 e raised to minus j omega whole power. Then what is the equation? General formula is going to be 1 divided by 1 minus alpha. Alpha is nothing but 1 by 2 e raised to minus j omega. This is what you will be getting off. In the same way, Obtain the frequency response of a discrete time LTI system. Here h of n is given as 1 by 8 into 7 by 8 power n u of n. Substitute, use the equation, frequency response equation, that is h of e raised to j omega is going to be summation n varying from minus infinity to plus infinity, h of n e raised to minus j omega n. Substitute for h of n, then u of n gives the limit, that is 0 to infinity, n is going to be varying. Then 1 by taken outside, leftover part is of 7 by 8 e raised to minus j omega power n. Again use the equation, will be getting as 1 by 8, 1 divided by 1 minus 7 by 8 e raised to minus j omega. Same question, here it is given as x of n is given, that is 1 by 2 power n u of n, and y of n is given as 1 by 4 1 by 2 power n u of n plus 1 by 4 power n u of n. Given equation written, then taking DTFT for x of n and also for the y of n. What I can get, x of e raised to j omega is equals to, we already come across this equation, right? So I can write as 1 divided by 1 minus 1 by 2 e raised to minus j omega. Then y of e raised to j omega as 1 by 4 divided by 1 minus 1 by 2 e raised to minus j omega, because 1 by 4 is there. Here 1 divided by 1 minus 1 by 4 e raised to j omega. Then x of e raised to j omega is equals to y of e raised to j omega divided by x of e raised to j omega. Now you substitute for y of e raised to j omega and x of e raised to j omega, that I did here. Then take the LCM and go for the modification. This, observe here, instead of going on multiplication, this denominator of the denominator is going to be in the numerator, right? This whole is going to be multiplied with this factor. Therefore 1 minus 1 by 2 e raised to minus j omega into 1 minus 1 by 2 e raised to j omega, it is going to be cancel off. So I will be left with 1 by 4. Then plus this in the numerator is there. So 1 minus 1 by 2 e raised to minus j omega divided by 1 minus 1 by 4 e raised to j omega, you will be getting off. Then 1 divided by the whole part, then minus 1 by 2 e power minus j omega the whole part. Here it is written. We wrote the equation. From this, taking the inverse DTFT, the impulse response is going to be h of n is equals to 1 by 4 delta of n plus, here what is a value, that is 1 by 4 power n u of n minus 1 by 2 1 by 4 power n minus 1, because 1 u of n minus 1. This is what impulse response. From this, taking inverse DTFT on both sides using of a time shift operation, I can write as y of n minus 1 by 4 1 by 4, h of n is of I think, just wait here.